All right, everybody. So good evening. My name is Dustin Hodgson. Thank you for joining us today. I'm the director of the Office of Professional Programs within the Department of Professional Studies, and I want to welcome you to the UMBC Software Engineering Virtual Open House. I hope that you enjoy this session, this particular presentation. And without further ado, here is your graduate program director, Dr. Sridevi Simpat.
So welcome this evening to learn about our software engineering programs. We are very excited about this program. It's a new program that's being launched this upcoming academic year. We have done several studies that have shown a very promising job market for this role of software engineer, and we are bringing in a lot of good curriculum supported by industry practitioners and the state of the art in the industry. So I'll tell you all about that as we get into the program. I am Dr. Sridevi Sampath. I'm the interim graduate program director, and that's my email address if you need to reach me. And Dustin, who introduced me, is the director of Office of Professional Programs, and that's the email address softwareengineering@umbc.edu that you need to write to reach Mr. Hodgson. So software development. Well, maybe before we start, since we have, is it 3 participants, Dustin? Would folks like to tell me if they have software engineering or software development experience, or if they are, career changers and they are coming into this field? It would help me to know the audience a little bit better, if that's okay, Dustin.
Absolutely. So Anthony, you want to start us off?
Yeah, I just recently graduated from the systems engineering program at UMBC. I learned a lot from it. I have never been a software engineer, but there's a contract that I'm on that has a software engineering component. I myself do not like programming, but I like the management of it, the development of it. So that's why I'm into this software engineering program.
Okay. Michael, would you like to go next?
Sure. I'm actually finishing my bachelor's over at Towson in business administration, but I'm looking to get into the IT field. So I've done some self-studying, some LinkedIn learning, and I'm looking to be a software engineer. So I'm interested in hearing about this program.
Very cool, Michael. Welcome. And Sunil?
Get off mute. Sunil here. Yeah, I'm a computer science major and currently really in the DevOps space. So it's in terms of computer programming and engineering, I'm going to say 50% of my time. Rest is dealing with APIs and other types of aspects.
Okay, welcome, Sunil. Okay, so we have a combination of people who like management, who are just starting out into the field, and who have been doing some software development. So I'll keep my talk pretty at a broad level, so we touch or work with all the audiences and their backgrounds. So software development has traditionally, or up until a few years ago, it was software was developed in a very ad hoc fashion, which means that organizations and companies were just doing whatever they needed to do just to get the software developed and built and deployed at the end user's organization. So software engineering, though, is defined by IEEE, which is a technical organization of electrical engineering, computer science professionals. They have defined software engineering as the application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software, and the study of these approaches. So this is particularly referring to the application of engineering to developing software. So development, you can think of software development as just an ad hoc way of doing whatever that needs to be done to build the software and push it out. But when you think of development in a systematic fashion, that means it is repeatable, which means that you can apply the same process over and over again to produce the same quality of software over and over again. That is systematic. When development is systematic, it gets closer to this definition of software engineering. When software development is disciplined, which means that there are certain rules, processes, and techniques that are followed in a disciplined fashion, then software development gets closer to this definition of software engineering. And then there's quantifiable, which is being conscious of how the software process, development process is working, and keeping those measurements, keeping track of measurements, and keeping track of how those measurements are doing over time. Are we able to meet deadlines with this particular software development process? Are we able to produce high quality software, which means not too many bugs once the software is deployed? So those are kind of measurements or metrics that can allow us to develop better software. So when software development is guided by these principles of being quantifiable, it gets closer to this definition of software engineering. So software engineering is all of these three things, and it's not only with respect to the development of software, but also its operation, which means once it's in the field, how it's running, how it's operating, and also maintenance, which is this last term here on that second line, which is once one version of the software has been developed and deployed, and now you have changes that need to be made to the software. How do we do those changes? Do we just do them ad hoc, or do we follow a systematic, disciplined, quantifiable approach to it? And when we do, we get closer to this definition of how software should be engineered, how software should be developed in practice. So software is one thing that is literally everywhere nowadays. It's not limited to only some software that is running on a computer. Software is on your phone, software is in the car, software is probably in a scooter that a child drives, software is in a toy car that the child is playing with. Software is literally everywhere. It is present in the manufacturing sector, in the defense sector, healthcare, finance, even software that is crunching data. You hear the term big data nowadays. Even that software, that crunching of data and analysis of data is being done by software. Even a software that is analyzing images and doing some machine learning or doing some AI, there is a software behind it that's actually doing that. So regardless of which sector you're looking at, software is there. And software is likely to be there for several years to come. It's a highly sought after job, software engineering. There was a survey by Burning Glass, which is a labor market analytics system, and they found that there were 29,000 postings for the role of software engineer within the last 12 months in Maryland alone, right? And that same labor market analytics system is seeing that there is a growth in the need for software engineers even within this Baltimore area, more so than other geographical areas. UMBC in particular is very well positioned because there are many tech companies, both private tech companies and defense organizations that are in the business of writing and delivering software. So software engineering is a skill that will be useful to find positions in all of these different places. The US Bureau of Labor and Statistics has found that software engineering jobs are expected to rise by 22% in the next 10 years. And that's a much higher rate of growth than other disciplines. And the pay is not bad, right? At the end of the day, we want to get a paycheck. And the Bureau of Labor and Statistics indicates that you can get up to $110,000 on an average. The median pay is $110,000 per year. So definitely, software is present in many sectors. It's not just limited to software that runs on a computer. And software engineering, which is this discipline of developing software, is a job title, or a job role that is expected to be there for the next several years that we can foresee. Now, I know some of you are coming in with some software engineering background, some are just getting into this space, But this is a software lifecycle model, one of the lifecycle models that shows the cycle in which software is developed. So it starts off at the bottom here in item one over there, 1 and 2, which refers to planning and analysis. So during this phase, requirements are gathered from clients who want the software built, and then they are trying to figure out, software organizations are trying to figure out, well, what do we build here? How do we build it? What kind of input does the system take? What kind of output does the system produce? And things like that. Then the software moves into this design phase, which is where architecture decisions are made. What kind of hardware does the software need to run? What kind of interoperable software does the software need to do its job? And then finally, implementation phase is the phase that probably most have heard of, which is developing software. Right, so that's the stage at which these design documents and the requirement specification that's created here are used together to actually write code to build the software system. Then we move into the testing phase, where we are making sure that the software does not have any bugs in it. Then there's an operation stage, which is the deployment stage. Once the software is developed, tested, and it's deployed at the end user or the client's organization. And then we go into the maintenance stage, which is when the software has change requests, when new versions of the software need to be developed, or when bug fixes have to be made. Each time a new release is made for the software. And so that at that point, the software is said to be in the maintenance phase. Now, a lot of times what I hear is people think that in the software development lifecycle, software developer is the only role there is and the role that needs to be filled. But I want to draw your attention to several different roles that one can take up in this lifecycle and peacefully coexist with all the other roles. So let's start off with this planning phase at the bottom here. So you may see job ads which are searching for product owners, or which are searching for business analysts. These users or people in these roles are involved during that planning phase. They are the ones who are talking to the clients and really identifying what is the need, what does the client really want, what do they want built, what features do we really want to put into the system that the client wants, right? Translating that language between the client and the software that's eventually going to be built. You may have heard of these roles of business analyst or database analyst. These are the folks that are identifying the business requirements of the software. So the kinds of things I mentioned earlier, what needs to be built, what kind of data is going to go into the system, what kind of data is going to be output from the system, and so on. In the design phase, you'll see roles like solutioning architect or system designer or UI UX designer, right? So these are folks that are involved with identifying what underlying software support is needed for the software to run, which programming language is used, and which hardware do we want to use, and what is the network requirements for this particular software system. And if the software is a product which has a user interface, then UI UX is another UI UX designer, which stands for user interface, user experience. They are the folks who are designing the user interface. And there you can bring in like an arts background and combine it with a computing background and get into that role of a UI UX designer. And then the term that we have seen most often or we think is the main role in software engineering is that of the software developer, who's mainly doing that implementation stage, or in that implementation stage of the life cycle. So these are folks who are actually writing the code, using the programming language, looking at the documents that are produced in these earlier stages, and then translating it into code, which then delivers the product. A lot of the software is moving to the web nowadays, so you'll also see roles like front-end developer or back-end developer or full-stack developer. Those are typically roles associated with software that runs on the web, on the internet. So a front-end developer is the one who's mainly involved in the browser, part of the code that runs in the browser, whereas the back-end developer is involved with the back-end of the software, and a full stack developer is one who knows both of those things. There's also DevOps engineer. This is another term that you may see, or another role that you may see in job ads. A DevOps engineer is more on the operations side of things, but they are interested in how do we, DevOps is this new way of developing software, and they are interested in setting up that process of DevOps and making sure that it's followed during the implementation of the code. And in all of these roles, I want to highlight that you can start off as a junior analyst, a junior UI UX designer, and move on to a senior UI UX designer. Start as a junior developer and move on to a senior developer. And then in this developer role, there's also this role of a technical lead who is mainly almost working like a project manager, but for the development piece of the software. Then let's move into the testing lifecycle. So here you will see roles like software tester, or software quality assurance specialist, or user acceptance testers, or quality engineer. These are all roles that need to be filled in the software development lifecycle, and those are the folks who help with testing and integration of the software. When you're trying to put different pieces of code written by different developers together and making sure that they are all working, those interfaces are working correctly, that's called integration testing. So the tester and the quality assurance folks are involved with that piece. And then in the maintenance stages, when you have new change requests coming in or bug fixes coming in, then again, the developer would get involved, and then there's technical support, which is not really a software engineering role, but then that is a role that shows up once you're in that maintenance phase of the life cycle. So what I want you to take away from this slide is that software developer or software engineer are not the only two roles one can fulfill in the software development lifecycle. We talked about how software development can be a engineering discipline. And so when a systematic process is followed in this fashion, there are several different roles that people can take on based on their background, based on their interests. And then, of course, there's a project manager who's kind of in the middle, in the center of all of these different roles. They are the ones who manage the deadlines. They are the ones who decide the deadlines, decide the schedule. They need to be able to communicate with all of these different types of users who are very specialized in what they do, and learn or understand what they are saying, and then come up with a schedule that can be met and that meets the client's needs. So developer is not the only role that you can be. Depending on your interest, depending on your background, you can fit into any of these roles. And our courses are also structured, and I'll bring this slide back again when we talk about courses, and I'll show you how our courses help people develop a well-rounded experience, but then you can focus through electives on one of these roles to specialize in that particular role. So a little bit about me before we go forward. I am, as I said, Sridevi Sampath. I'm the interim graduate program director for this MPS program in software engineering. I'm also an associate professor in the information systems department at UMBC. I got my PhD from the University of Delaware, and I engage in research and teaching as an associate professor. And my research interests have been in this area of software engineering and software testing. I've been at UMBC 15 years, and I bring in a wealth of experience both as an educator and a researcher and a program manager, because I'm also the undergraduate program director in the information systems department, where we have like 2 majors and several certificates. I'm affiliated with the NIST ACTS group, which stands for Automated Combinatorial Testing of Systems, and UMBC's Center for Cybersecurity as well. So let's get into the programs themselves. We are offering 2 software engineering programs. One is a graduate certificate, and the other is a Master of Professional Studies. The graduate certificate has 4 courses, which amounts to 12 credits, whereas the MPS has 10 courses in it, which amounts to 30 credits. Now, one question that comes up is, how is an MPS different from an MS in information systems or an MS from computer science? And just in our audience today, we have somebody from a business background, we have somebody from a computer science background. So it's a very valid question to have. So the MPS program is designed for practitioners. It is often taught by industry practitioners, and it is designed to teach the skills that are application oriented, that are industry oriented, that allow you to get a footing into that job space of software engineering. Whereas an MS in information systems would be somewhere between application, would have it is applied information systems, applied computing, but there's also a little bit of theory involved in the MS. Whereas the MS in computer science is more on the theory side and a little bit less than the MS and the MPS in terms of application orientation. So that's kind of what an MPS in software engineering would provide. It's a lot of industry-oriented, career-oriented skills that help a graduate get into the space of software engineering and pick up one of those roles depending on what their interests are. The classes are going to be at the UMBC main campus, which is in Catonsville, which is this red star over here. We already have one UMBC graduate in the audience, and then Michael said he's from Towson, so you should be familiar with where UMBC is. So let's start with the MPS. The MPS has 6 core courses: a course on ethics, a course on the basics of software engineering, a course on structured systems analysis and design, which, if you remember my life cycle that I showed you, this is focusing on those steps 1 and 2 that were at the bottom, actually 1, 2, and 3 that were part of the life cycle. Then a testing class, fundamentals of software testing, which, if you remember, was also on the life cycle graph. And then to make sure that people who are interested in management have the background to get into that, there's a management class that you can take, ENMG 652 or IS 765. And then the capstone in software engineering is really cool. It brings in all the different things that you learn from these individual courses and allows you to work on a truly distributed software system that and build that software system using some of the latest tools and technologies that are used in the industry. Before starting this program, we surveyed several industry professionals and asked them, what are the skills that you see that are lacking or that you think would be really good to have for somebody entering into the software engineering space? And so one of the things they mentioned is this ability to know all the latest tools that are used during development, using a tool like Docker, or using a latest tool for testing, or using a content management system, whatever is the latest that is being used for in the industry. If people come in with that knowledge, then there is less of a learning curve once they are in the industry. So the capstone is really bringing in the concepts that you have learned in all of these different classes and allowing you to work on a software system, develop a software system in this truly distributed fashion in which software is built today, right? You have people working in the US, working with people in Ireland, working with people in Spain, and all of them together are building a software. And that is not easy. There are challenging aspects to it. So we are going to bring in a lot of those real-time distributed environment learning experiences through this capstone course. And then you have the option of electives where you can specialize into one or more of those roles that I mentioned. So the core courses, there are 12 credits. So the systems analysis and design class, the advanced software engineering class, the testing class, and the capstone. You can think of them as the core courses that deliver to you the basics of what software engineering is and all of those different pieces of the life cycle. Then through these management classes and ethics, right? Ethics is so important when we are working with a software system. It's actually important in all professional settings. And it's also important when you're working with software systems, the kind of regulations that software has to follow and the kind of compliance needs that are there and that need to be met is all something that you will learn through the ethics course. So these courses, the courses that you see in the yellow bubble, give you a breadth of knowledge in terms of learning about management and ethics. And then through electives, you can specialize into either, you can choose to go more into development, for example, by taking these CMSE electives, or you can go into management by taking this SENG course, process management, or you can go into the UI UX side of things by taking this HCC 629 course. And then there'll be special topics that are offered based on the latest industry trends that are in the market. And so you can choose a particular special topics based on what your interests are. And then we also have some electives that allow you to go into the big data space if that is your interest. So the electives, you have to do 12 credits, so that's 4 courses. So you can choose to do a variety of them. Some of these electives may have prerequisites, so you may just need to be aware that you have to take those prereqs to actually succeed in these electives. And if you'll see, this program that's being designed here is a program that has courses from both information systems department at UMBC and the computer science department, and then some core SENG classes as well, which is a really unique thing about this program. So it's not just about development, it's not just about the theory, which is what you may see in a computer science software engineering program. And it's not just about the business side of things, which is what you may see in an iSchool software engineering program, but it's kind of a really good amalgam of these two different areas. So I told you I'd bring this figure back here to show you how our courses would help you transition into one of these roles in the software engineering job world. So let's start at the bottom there, the product owner, system analyst, or business analyst. The skills that you need to succeed in those roles will be taught to you in these classes, which are 2 of those are core classes, and 1 of them is an elective. The skills that you need to succeed in this analysis phase, if you're more the business side of things, if you prefer to be more on the client side of things, then SENG 636, which is one of our core classes, will help you with that. If you prefer, again, to be on the client side, but also be involved with the design, with the architecture, and solutioning architect is one of a coveted positions that developers try to get into, because there is always going to be need for somebody who can really develop an architecture. So SENG 636, HCC 629, those are courses. One of them is a core course. The other one is an elective. This is the elective on user interface design. In the development space, there are some SENG courses, the capstone course. We'll be offering several special topics as the program continues, where you'll be able to learn different development skills. And then the computer science electives that I showed you on the previous slide, they would be well suited for somebody who really wants to get into development and not be involved in these other, not be involved as much in these other steps of the life cycle. SENG 740, which is one of our core course, will train you to get into that testing space. And through our special topics classes, both in the SENG program and the IS program, we have had courses offered on software maintenance, where we look at all of the different challenges that occur in maintenance and how to address them. So you can see that the curriculum that we have developed, that we have planned for our MPS students, will give you really a well-rounded background. And then there's the project management class, which will help you with if you want to get into management as a project manager. And then there's the ethics class, which I cannot stress enough how important that is to really be a successful professional in the industry, which will deliver to you through one of our core courses. So you'll really have a well-rounded experience, well-rounded background, and then through our electives, you can specialize into one of these, one or more of these roles that you see on this graph here. The graduate certificate has 4 core courses, 12 credits, and those are the courses that you would need to take. There's advanced software engineering class, systems analysis and design, the testing class, and the capstone. Now, one of the things that if you search online or if you talk to professionals in the industry and ask them, well, what do you really need in a software engineer, And this is what we also saw when we did the survey I told you about. So programming and coding is one bullet in the list of skills that they like to see in their software engineering professionals. Communication is an important skill. These are, you can think of them as soft skills, but they are very important skills that come up over and over again when we talk to our alumni, when we talk to people who have been in the industry, and they tell us, well, these are some of the things that we would look for. Yes, you need to know how to code, you need to know how to test, or you need to know how to design, but that's one of the things that we look for. But we look for communication, we look for teamwork, we look for ability to solve problems, we look for attention to detail, which is basically being able to document your things and document your deliverables, make sure you follow the systematic process that has been outlined and things like that. So through the courses, the way we have designed our MPS courses, there's going to be a lot of team projects where you'll be working with other folks, other students in the class. Communication will be very important, and it's all project based. So a solution will not be apparent. You really have to communicate with the team and develop a solution which really goes into the problem solving piece. And there'd be some writing as well, because documentation tends to be one of the important aspects of software engineering. If you look at the agile space, the software, which is a development process, there's less of an emphasis on documentation, but there is still documentation. They still do user stories. They still have a process that they follow there. So through our courses, we would be reinforcing that attention to detail aspect as well as a workplace skill. So you're not only going to have the technical skills that you need to succeed as a software engineer, but you will also develop the soft skills, the workplace skills that you need to succeed as a software engineer through our MPS program. Now, the courses, we are going to staff them with industry practitioners who are actually software engineers in the field. So they'll bring a wealth of industry experience into your classes. As I said, an MPS is an applied program where there is an emphasis on training students so they can get placed in the job industry. Now, this faculty advisory board are tenure track faculty in the information systems and computer science departments who are going to be critical in the development of this program. And as this program continues in terms of working with the industry practitioners and in terms of reviewing syllabi and things like that. So one of the strengths of UMBC is that it's a very strong research university, and several of these faculty you see here engage in research in software engineering. So they would bring in, or they would advise the faculty teaching the classes on how to bring in some of their research into these classes. And so you can really get an experience that is well-rounded, both from the industry side and a little bit of research as well. So you'll get the advantage of being in a rigorous research-oriented university that UMBC is, while still learning the practitioner skills that you need to succeed as a software engineer. So some of the strengths of the program are that the courses have been developed by faculty with years of experience in this field of software engineering, along with industry knowledge. So we know what is being used in the industry, and we have incorporated that into the courses that I showed you. The program is also flexible. It will have face-to-face classes. It will also have hybrid classes. In the fall, especially, we envision classes to be hybrid, which means that you come in sometimes, that the Sometimes the classes will be online. Classes are offered during the evening hours to accommodate working professionals, and it's also flexible in terms of what electives you take, right? So if you look at our list of electives on the course website, you'll see that there are electives that you can take from computer science and electrical engineering or information systems, depending on what your specialized interest is. The program is also agile in the sense that we will constantly be looking at industry trends and offering special topics in that area of interest. And we would also be updating our existing courses to keep up with what's happening in the industry. Software engineering is really a rapidly changing field in the industry. A programming language that you used 2 years ago may not be used 2 years later. There are some languages that have lived forever, like Java and Python more recently, but there are other tools and techniques that change, and so we have to be agile, and we are very cognizant of that. And in terms of opportunity, remember that you are coming to UMBC and you are getting not just a degree or a certificate, but you're getting everything that UMBC has to for you as an opportunity to grow as a professional and to experience the discipline. So you will have, first of all, the geographic location is a bonus. We cannot deny that. There are a lot of technology companies and defense organizations that are in the business of developing software. But UMBC itself has several professional networking events. The computer science department and the IS department often host webinars, industry talks that you can go and attend and learn about what's happening in the industry. You can use the Career Center to enhance your job searching skills. They can help you with how to hunt for jobs, how to build your resume. So there's a lot of opportunity that you get from being in a university like UMBC. It's not just about earning a certificate or earning an MPS, but really this well-rounded experience that UMBC is able to provide. The admission requirements of the program is that you have to have a bachelor's degree with a GPA of 3.0 or higher. We are asking for introductory programming courses completed within the last 10 years. If you don't have introductory programming courses within the last 10 years, but you have been in IT and you have been writing code and you have programming abilities, which can demonstrate to us that, well, yes, you know, programming, that can be considered as a substitute for this requirement. And if you are a career changer, if you're coming in from a completely different background like law or from a healthcare background, and you want to get into computing and software engineering, then we are asking that there are some courses that you can take, and I can help you identify the courses at UMBC, or you can take them at a community college to show that you have that programming background. Some college level math is useful as well. So we do have a requirement of college level math, which equates to calculus. If you don't quite have calculus, but you have something else, but you have a year of college math, then talk to us and we may be able to work with you on that. GRE scores are not required. And for international students, that's the requirement depending on which test you have taken to demonstrate English proficiency. The application has to have these components in it. It has to have an official transcript enclosed, the English proficiency score for international students. We are asking for a resume and a statement of purpose that describes your interest in this program. And there's a $50 application fee, which is waived for this fall year. If you use that code when you're filling up the application form, the fee will be waived. Now, in your statement of purpose, it would be really useful for the GPD to see what your background is, why you're interested in software engineering, why you're interested in UMBC, and how you have met the requirements that I talked about 2 slides ago, the introductory programming courses and the math, how you have taken that previously, or how you meet those requirements. It would be really useful to be able to see all of that when we are looking at your graduate application. So that brings me to the end of my slide deck. Thank you for your attention and thank you for being here this late in the evening. The website seng.umbc.edu has more information about the MPS and the certificate. If you have any academic questions, if you have questions about the program, if you have questions about the industry, if you have questions about is there really going to be a job for me at the end of this, or some things like that, or if you have questions about, well, what's taught in this course and what is taught in this course and how are these courses different, and will you be teaching this in one of your courses? Those are academic questions which I can happily answer for you. That's my email address, sampat@umbc. And if you have any administrative questions, then Mr. Hodgson is your contact for that. And he can be reached at softwareengineering@umbc.edu. So do apply if you're thinking about earning this MPS, or if you want to start off with a certificate and then you want to think about getting into an MPS, that's also an option. And if you do apply, remember to use that code to get the application fee waived. So that brings me to the end of my slides. I am happy to take any questions.
I have a question.
Yes.
Yes. How much programming will be required in each classes?
So 601 and 636 will not have programming. There'll be more, 601 is more an ethics class, so there may be a bit of writing involved and definitely reading. 636 is mainly focusing on those initial phases of the life cycle. So there you'll be doing a lot of diagramming, a lot of analysis, a lot of communication, teamwork, and there won't be any coding there. 645 is likely to have some coding. 740, which is the class on software testing, will have coding in it. And then 701, which is a capstone class, will definitely have coding in it as well. This class is a management class, and you'll be learning more about tools and charts and things like that that help a program manager, project manager manage the project and manage the schedule and things like that. So there won't be programming in that class either. So 3 of the classes will have programming in the core courses, and then the other 3 will not be programming heavy.
Got it.
Other
I
questions?
wasn't quite sure how much more programming classes I should take at the community college.
I would say if you have these the requirement courses that I have here, you should be in a good shape. If you take this 147/247 equivalent or CMSE 201, CMSE 202 equivalent, you'll be in a good shape. If you want to learn more about programming, if being a developer is one of the roles that you want to get into, then maybe taking a data structures course would also be helpful. Something that is looking at stacks and queues and things like that, hash tables, and talking about the pros and cons of each of those structures and how to use them. That would be a useful class to take if you want to. And I can talk with you offline if you want to share your transcript with me, and we can go over that.
I took a lot of those classes, like discrete math, assembly language. Yeah. I mean, I did well, but I never feel like I knew well.
Okay.
Yeah.
I think programming is one of those things that one gets better at with more and more practice and more and more experience. So it's okay to feel shaky in the beginning, but then as you get through all of this coursework, I think you'll develop more confidence in that, if that makes sense.
Thank you.
I did have a question, I guess, about the introductory coursework. So if someone were to share a link, I guess, to their resume, would that be considered in the admission process?
A GitHub link to GitHub?
Yes.
I'm sorry, you broke up there, Michael, for a little bit. Sorry, I'll ask for a clarification. I think it would be useful for me to see, or for the graduate program director to see what kind of programming projects you have done in GitHub. So definitely, if you're applying for any programming related or software engineering related position, including a link to GitHub is good. But I think we are looking for either industry experience or coursework experience. So if somebody developed code just as side projects, I don't know if that would be sufficient enough as to meet this admission requirement. But I'd definitely like to see it. So please do include the GitHub link.
Okay, that makes sense. And I do have another question. So,
Absolutely.
if I'm applying for the spring admission, would I be able to take the introductory courses at the same time I'm starting my first semester here?
So some of these classes will be offered every semester, and some of them will be offered one semester or the other, alternating semesters. So I think by the time you finish, you'll have had the opportunity to take all of these courses. But maybe Dustin has more information on these courses, like the ENMG 652 course. I believe it's offered every semester. SENG 636 is going to be offered every semester. So there would be core courses that we can place you in, even if you start in the spring semester.
And Michael,
Okay, thank you.
are you graduating the spring of 2022?
I'm graduating this fall.
I see.
I'm looking to
Okay.
start next spring.
I see. Okay. Yep. Understood.
I guess I have another question before you guys go. As someone that does not have a technical background, do you have any additional documents that you would like to see from people without a technical background?
I think if I am able to see this coursework, I'm sorry, I keep going back and those animations are not helping. If I'm able to see this programming background, courses through coursework, and the math, I don't think I need additional documentation from them. If they can explain in the statement of purpose, their passion for software engineering or why they are changing disciplines, that would help. That would be helpful. But these are the main admission requirements. As long as they have this, they should be in a good shape. And this program is designed for keeping those career changers in mind. So I would definitely encourage that person to apply. We really thought about, well, what if somebody who's in the bio field, who worked in bioinformatics or who worked purely on the science side of bio, they want to switch into software engineering? How can we train them for that? And how can we train somebody from a law background to get into software engineering, or a nursing background to get into software engineering? And we developed the curriculum keeping those people in mind, career changers. And so as long as these admission requirements are met, I don't think I would need anything more.
Thank you.
Sure.
I guess this question would be for Dustin. I'm pretty sure I started my application for this program already for spring admission.
Okay.
That being said, how would taking the introductory courses in this upcoming fall semester, what's the best way for me to, I guess, communicate that with my application?
So let me understand your question. So you're graduating at the end of December, correct?
Yes.
All right. So what you're asking is if you're taking some of the prerequisite courses that correspond with the requirements. Is that what you're saying? How will that shape you up for admission for the spring?
Yeah, so if I submit my transcript now and it
Mhm.
doesn't include these courses, what's the best way for me to let you guys know that, hey, I'm taking these courses in the fall?
I got you. So what we can do is just email me and we'll keep a record of that information. So potentially what we can do is we can put your file on hold. So we can have it in a holding status. As you complete your requirements, we can finalize your application. And once it's finalized, we'll forward that along to Dr. Simpath. once you have all of the required documents so that she can review you. So you can work with us closely, and quite frankly, just feel free to email us or email me specifically with that email address, and we'll keep your file active while you're finishing. And once that's done, and all the requirements are together and complete, that's when we'll be able to forward everything to Dr. Sempath.
Okay, that makes sense. Thank you.
Mm-hmm. Guys have great questions today. That's fantastic. You guys are on the ball. All right. If you guys don't have anything else in terms of questions, you have both of our emails. So feel free to touch base with us via email, because I know that what tends to happen is when you close a meeting, you're like, I forgot to ask this or that. So you have that information at your fingertips. So feel free to touch base with us anytime you need. We're definitely here to facilitate and answer any questions that you guys have about the program. But on behalf of myself and Dr. Sempath, I want to thank you all for taking the time to meet with us today. And like I said, feel free to get in contact with us if you have anything else that you wanted to chat more about.
Thank you.
Yep. Thank you all for coming. And send me an email, send Dustin an email.
Bye-bye.
Take care.
Bye.